All right, guys, this is 5.5, which talks about bases other than E. So it's going to feel a little similar to the last section, except that the base is no longer E, so you're just going to have to be careful. We're going to go through some basic log reminders and exponential reminders first, and then we'll get into some derivatives and integrals of these. So for today, it's going to be mostly review, a little bit of an intro for your derivatives. Okay, so just a reminder, change of base formula. It's going to be helpful here because of the fact that you might need to change some stuff around. So if you don't remember the change of base formula, a lot of us have a button in our calculator that does it for us, so we don't always have to memorize it, but you always take the log of the value, which is x in this case, over the log of the base. Okay, another version of this, technically that works out the same way, is if you take the ln, or natural log of the value, over the natural log of the base, it ends up being the same thing. Just a heads up that this is the same thing as 1 over ln of a times ln of x. That'll come in handy a little bit later. All right, some other properties, which we already talked a little bit about, but I just want to remind you. If you have a base and a log with the same base, those cancel and you're just left with the exponent. So you get x back. Okay, it's for x is greater than 0 because, again, you can't take the log of negatives. So note that. Same thing if you have log, same base, same value. It works the same way where it cancels. So it'd be like log base 5 of 5 to the 6. Your answer is just 6 because this actually cancels, which is sweet. I know I'm running through this really quickly, but these should be all reminders for you. To solve equations with bases other than E, get them to be, especially for exponentials, get them to have the same base. So like, what this means is I can turn 1 over 64 into a base of 4. First of all, I know it's going to be negative because this is a fraction. And then 4 to the third is 64. Once you have that same base, I know these have to be equal. So x is negative 3. This one, just a quick reminder, put it in exponential form or seashell it. So the base to 5 equals x. So 3 to the 5th, or 243. Again, running through these quick because they're refreshers for you. All right, this is the last little bit of our notes for today, so hopefully the rest of the day will feel pretty easy for you. You just have a little textbook homework, but it should not take you long. All right, solve each equation with a calculator. So take your calculator out. Get the base alone first, then you can plug it in. So divide both sides by 3. 5 to the x minus 1 equals, that comes out to be, let's just leave it as 86 over 3 for now. So with a graphing calculator, still want to show a little bit of work, but to get these to give the same base, you can't make this into 5 to some power. So instead, you can put it into log form. The other way that you may have learned this last year is if you take the log of both sides, it does the same thing. I think putting it into log form is a little faster. That means I would do log base 5, because that's the base. And then you literally just swap these two. So log base 5 of 86 over 3 equals x minus 1. You can either use the change of base formula if you have an older calc, so log of 86 over 3 divided by log of 5, or if you go to your math button, there's actually a button that goes straight to a log with a different base. Now, some of us don't have that log change base button, so I'm actually going to do the log of 86 over 3, close parentheses, and I'm going to divide it by the log of 5, because I don't have the new thing on this calculator for some reason. So you end up with 2.08 equals x minus 1, and then add 1 to both sides. So x is going to be approximately 3.08. Actually, that's more like a 9. I lied. Let's make that a 9 for rounding. So 0.9. Okay. And then for the next one, again, exponential form, when you see a log there, it's the easiest way to do this. So 8 to the 2.6 equals x minus 3. And if you do 8 to the 2.6 in your calculator, you get 222.86. So you have to add 3. 22.86 equals x minus 3. So add 3 to both sides, and you end up with 225.86-ish. Okay. All right, last bit, and then you're good to go do your textbook homework. Okay. Use the graphing calculator. So technically you could have done this for the top two, but I wanted you to show a little bit of work. I just want to make sure I rounded to the nearest thousandth, tenths, hundredth. I did not. Sorry. Didn't round to the thousandths. So this should have been 3.085. So it was close to the first time, and this should have been 225.861. Because they wanted thousandths. Anyway, sorry. Okay, so technically, yeah, you could have done this with the top two, but use your graphing calculator to find the zeros, round to the nearest thousandths. So this is another way to solve one of these equations. Technically, you guys could solve this by hand if you really wanted to. Finding the zeros just means you're looking for where y equals 0. And sometimes I find this a little easier to do by hand, but let's not do all that extra work. So instead, what we're going to do is plug y equals into your y1, into your graphing calculator. So go to y1, plug in that entire equation. You don't even need the base 10 because it assumes a base of 10 when you put it into your calculator. So if you just plug in 1 minus 2 log of x times x minus 3, you can even change this to x squared minus 3x, just in case if you're worried about parentheses being in there. But if you graph it, what you're going to see is, and actually I use Desmos for this just because it's easier, because you can actually just click on the points of intersection, but you're looking for these, the points where it crosses 0. Okay, so you can, on your graphing calculator, you can just do that with second trace or second calc 0, just follow the directions on the screen. Just be careful you want both answers, because if you plug them back in, they work. So x can be negative, just the log of a negative can't happen. So if you simplify it and you get a negative, that's where you have issues. So both of those answers work. And again, if you use Desmos, it's super nice because it just like, you click on it and it gives you the answer. So if you want to try it, please feel free. You have to just go to functions and then miscellaneous to find the logs. But this one is 3.826, and then this one is negative 0.826. So those would be your answers. All right, guys, enjoy the rest of your day. Have a good one. Hopefully this was nice and short for you.